So this has to do with, and we did some of this already. We did find the height of oblique triangles. And basically the height, if it's not part of the triangle, if it's not a side of the triangle, it is dashed. Right? So here, for example, you have something like a triangle that's slanted over. The height to the top would be measured straight down to the ground. So again, it's not part of the side of the triangle. If it's a right triangle, then obviously the height is one of the sides on the triangle. So these are the scenarios that you might encounter. But remember, you've got sine law and cosine law there always to help you out with these. So let's tackle a question right here. Okay, so Kat and Steve are hiking, and they follow a creek. So there's Kat and Steve, right, along this side of the creek. They're 20 meters apart. There is the 20. So the 20 goes from end to end. And they spot a pika, which is a small mammal, on the opposite side of the creek, as depicted here. So they're some distance apart. They're both looking at the same thing. And here is where the height of the triangle, it's the width of the creek, but we would still consider it the height of the triangle. Okay? So how do you deal with that? I would suggest to you, forget about the height at first. Like, try to ignore the dashed line. Look at the big triangle first. Okay? So what do you mean by that? Because, like, just face it. Let's say you want to find this height right here. Do you have a pair at all that you can use? Maybe you're thinking, 20 and maybe 17, they're kind of, no, they're touching. Remember, this side is touching 17, so no, you can't. W and 17, they're across from each other, but you don't have any other pair to work with here. So forget about the dashed line for a moment and just focus maybe on this big angle up here, which is across the 20 that goes from end to end. So I'm going to figure out angle P here first and foremost. Angle P is 180 minus 17 minus 36. That's 127. So you know that this entire angle here, right, from end to end is 127. So we're forgetting about the dashed line. We're not considering it. So we've got the 127. The 127 is across the 20. Because remember, the 20 belongs to the big triangle. This angle belongs to the big triangle. Okay? So we're pairing these ones up. So I'm going to go like this. Sine of 127 over 20 meters is equal to. And here's where you have to be careful. If you want from cat to pika, which side am I finding? I'm finding this side, right? Let's call it, I'm going to call it x. Okay. So in this case, if I want to find x, which angle am I going to use? 36. So you're going to go sine of 36 over x. So remember, I'm ignoring the dashed line for now. So I'm going to go cross multiply and divide. So it's 20 times sine of 36 divided by sine of 127. So that's 1472. 1472 meters. And this side belongs to, it's this slanted side right there. How far is Steve from the pika? So we're asking distance from Steve to there. Let's call that y. Guess what? I'm going to start with the same pair. 127 is across the 20, right? And now I'm going to use the 17, which is across y. So sine of 17, don't forget that. Don't just put 17 down. Your answer is going to be it's going to be off. You're going to notice. You should notice that. So I'm going to go 20 times sine of 17 divided by sine of 127. That is 7.32. Does that make sense? Is it reasonable? Which one is your greatest angle here? The largest angle? 127, right? It should have the longest side across from it, which is 20. If I compare to the other side, the other sides, okay, it is this makes sense. And having an angle of 36, right, should have a longer side across from it right here than the 17, which should have an even shorter. It should be the shortest side because it's the smallest angle. So keep that in mind. How wide is the creek? It's asking for W. Okay, listen carefully to this part. You've got both highlighted sides, right? You've got this slant and this slant. So you're in a very good position. You get to choose which triangle you want to use, which right triangle, right? But let's say you only knew what Y was. Which triangle should you be using? If you cut it here, you should be obviously using the one where you have the slant. So not always will you have both slant sides there. So you got to be careful with that. Let's use this one here. I'm going to call this 1. Let's bring this over down here. This is our right. This is W. We know that X is 14.72. We know that this is 17. So I'm just copying down from, let me see if I can try to get that on there. Okay. This 17 here follows me down here. The 90, if there's a 90 on this side, there's a 90 on the other side. Remember, this is a straight line here, so it adds up to 180. So 90 and 90 would make sense. I bring that down. And I have what I need. I have my pair. And I'm going to use 17 to find W. So you've got to be careful you don't mix up the triangles. So I'm going to go sine of 17 over W. So that's 1472 times sine of 17 divided by sine of 90. Remember, sine of 90 is just 1. I don't have the key readily available, so let's just go with this here. 4.3, 4.30 if you round it to 2 decimals. That's how wide the creek is, which is technically quote-unquote the height of our triangle. You should get the same answer if you approach it from this other triangle, correct? Like if you were to come from this triangle and use this side, you should get the same answer. If not, we did something wrong. Hold it. I'm going to clarify this one more time. The 1472 here, this one that we found, is across the 90, but it is also across, let's go across, way across the 36. But don't mix them up. If you're going to pair this one with a 36, you're now using the big triangle. You need to find another pair that is in the big triangle. If you're going to go 90 with this, remember, now you're in this triangle here, so you got to find another pair within that small triangle. So don't mix them up, please. Okay. That's that. I'm just going to review this part right here, if you come with me to 34. I'm going to I'm going to check your knowledge on this part. And there was one already on the AC yesterday. But if you see an angle that's outside the triangle and there's a straight line, guess what? They add up to 180. So subtract this one from 180 to get this angle. That's this one is supplementary. If you ever have, if you, for whatever reason, you have a right angle somewhere and there's a side cutting into it, that this is a 90 here. So this is on page 32. You're going to subtract that from 90 to get your angle inside the triangle. Okay. So keep that in mind. On your study sheet, it would be great for you to have this, complementary, supplementary, so you remember which one is which.